Okay, section 8, we're going to do the examples. Again, my encouragement to you is this. If you see a footnote, read the footnote. All right, the footnote gives you a very good hint about how to attack the problem. Right. We're not expecting you to memorize a lot of stuff, though. I mean, I shouldn't say some of your teachers expect you to memorize a lot. I don't really think memorization is a good skill. What I think is a good skill is, resilience, looking at something and saying, I'm willing to try doing this problem until I get it. Of course, we're trying to speed up the motion here by giving you hints. It's nice to have hints, by the way. All right. So we'll be giving you hints throughout. All right. So if 1 gives you a hint, 2 gives you a hint, 3 gives you a hint. And maybe, by the way, hints come to hard to take. 4 gives you a hint. All right. Whoa, that's a tough one. Looks a really nightmarish. 5 gives you a hint. Oh, look, 6, no hint. So I'm gonna say I gotta try something. I'll get there though. Let's take a look at. Oh, look at that. That's good. All right. So we did a lot of examples prior. I'm going to see if I can take their hints. By the way, if something gets overwhelming for me, I understand that. You can take a break, of course, and say, I got to take a break. I can't do this anymore, and come back to it. You'll get it. I kid you not. All right. So I'm gonna go to a share. I'm going to share my whiteboard with you, and I'm going to try to take their hints. The worst part about hints, you might not understand it. All right. So let's take a look, and I'm going to do this thing over here. And let me just make sure you understand what we're doing over here. Hint, rewrite tangent as a ratio and then use U substitution. We did this before, but I think many will not recall this, although nice to know it's not required knowledge. All right. In other words, they're telling me that this integral that they're giving me here, I'm not required to remember that. But here's the deal. What you're required to do is be able to work towards a goal. So I'm going to take their hint. What was their hint? Can't remember it, reread it. They said rewrite the tan in terms of sines and cosines. Well, you know what? That's something that your teachers would have told you in math 120. They said that it's probably easier to look at things in terms of sines and cosines. Now, what's the next thing I would do? Well, looking at it, again, in the hint, they kind of tell me, they say make a U substitution. They just tell me what U substitution they want. But I'm looking at it, and I'm going to say clearly, U would be cosine of X. What's du? Minus sine X dx. I'm going to do that now. A little star here to remind me. So let me see. I would get minus 1 du over U. I can remember that. That's something I need to remember, right? There's not a lot you need to remember. You should remember the answer for that. That's minus the natural log absolute value of U. What's U? Cosine of X. Plus C. And that's an answer. All right. Now, by the way, they didn't say that though. They said this was the answer. So I'm looking at how the hell did they get that? So if you look at this over here, you should know something about logs. And when you get over here, this is a natural log of the cosine of X to the minus 1 power. No, that's not an inverse. And what's that going to be? 1 over cosine, which we know to be the secant. All right. This is typically the way they want to write that one down. Okay. They do put work over here, and the work really isn't that bad to do that. All right. We just did the work. Let's go to the next one, number 2. Number 2, I want to take the hint. That's a hint number 19. I'm going to pull it up here. Right. I'm going to put this, let me get this together. And I want to take their hint. All right. So what does it say? It says hint, rewrite integrand, multiplying it by a unit factor. Geez. Let's put this down. So what would you get? You would get secant of X times, well, let's see, they said multiply by that unit factor, right? So secant X plus tangent X, secant X plus tangent X dx. Well, someone looked at that and said, that's crazy. It just makes the Integrand so much more difficult. I don't know. Let's keep going. All right. So what would I do over here? I guess, I don't know. I guess I'd look at it and I start to think, do I know the derivative of that? I think I'm seeing something. So I'm going to say u, let's give it a shot, is secant x plus tangent of x. And again, it might be wishful thinking, but anyway, they gave me a little hint. And what's that going to be? The derivative of secant is going to be secant x tan x. And the derivative of tangent secant squared, isn't it? Well, what do I notice immediately? I see it. What's that guy over there? It's secant squared plus secant times tan x dx, which we know to be du. Let's write this down. What's on bottom? U. What's that guy's antiderivative? Fairly simple. It's the natural log of the absolute value of u plus c. What's u? We just did it. It's secant x plus tangent x. So I took their suggestion, and are we getting what they said we should get? Wow, we got exactly what they said we should get. Let's do the next one. This is problem number 3, another footnote over there, and they're basically saying do the same thing. A different unit though, right? Let's write this over here. Again, I may have to remind me something here. It's always possible I can't remember. So they said multiply it by this. Let's write this down. It's a unit builder, by the way. So again, it says rewrite the Integrand, multiplying it by the unit factor. We just did that. And then use a u substitution. Well, let's try it. All right. I want to remind you that, when you go through life, you're going to forget a lot of stuff. So my recommendation to you is at least have some tools that allow you to jog your memory. So for example, I would like to know the derivative of cosecant. If you can't remember that, I want to point out what I would normally write down is, I would write down it's really sine x to the -1. And if I were taking that guy's derivative, and again, I'll erase this in a second, it's -1 sine x to the -2 times the cosine of x. What would that give me? That would give me minus cosine x over sine x sine x. So what does that give you? Du, well, that's pretty simple, minus cotangent x times cosecant x. So I just did that guy's derivative. I'm going to get my little eraser out. Erase this business over here. And let me see if I can jog my memory about the derivative of the cotangent. Now, granted, I'm not saying you can't remember. All I'm saying is it might be nice to be able to derive things. What's a cotangent? That's going to be cosine, I'll say x, over sine x. And I want to take its derivative. What's derivative? Let me write this down. I'm going to erase it in a second. Square the bottom. That's sine x times derivative of cosine. It's minus sign, right? Minus the top times derivative of the bottom. Well, isn't that convenient? Top is -1 and the bottom is sine squared. What's that mean? It's minus cosecant. So minus a minus is plus, right? And that's going to be dx, I'm sorry. All right, let's look, see if we see it. Wow, it's a miracle. So what do I see? I want to circle it for you. This is this. All right, we get the cosecant squared and we get the minus cotangent x cosecant. Let's write that down for you now. So what do you get? 1 du, and cosecant x minus cotangent x is u. So what do I get? Another really kind of convenient result. Natural log, absolute value of u, plus c. All right, let's look at the k. See how we're doing. Geez, we got that one right too. All right. Again, someone's gonna say, I can't remember that. And I'm not asking you to. All right, I'm asking you to, it's, look at it, see if you can do that. Give it a hit, that's nice. Let's keep going. Whoa. Integrate. All right, this looks tough. I'm looking at it. And I guess what I would do is, I don't know, I got to do something. Let's put this over here. I sort of like tangents and secants, right? By the way, I'm not saying any one way is better than the other. I'm just saying you got to get moving. So I got, including you going down a dead end, at least you're moving. The worst thing to witness in life is when people get stuck and they don't know what to do. Okay, I'm going to keep looking at it. And I'm going to write that down again. Oh boy, I guess I got to do something, right? I'm going to try integration by parts. Not saying it's going to work. U tangent x. Now, if I do that, I am forcing myself to say that dv is equal to tan x secant x dx. Well, this isn't so bad. So du is going to be secant squared x dx. Now the integrations are always difficult, but I'm thinking I kind of remember just doing something like this, right? So the derivative of secant is going to be tan x secant x. All right. So let's see if we can do this. I'm going to come over here. And that's going to be uv, like a tan x secant x, right? And this could be a dead end, by the way. Minus, let's see. We're going to get v times du, which is secant cubed. All right, got troubles right now. By the way, my troubles are as follows. My original integration didn't get much better, but I'll be honest with you, it didn't get much worse either. All right, the original integration was, that tan squared secant. At least I got it boiled down to a secant cubed now. So then the question is, you scratch your head and say, what am I going to do now? And this we're going to say it's nice to have some prior knowledge, not a memorization, by the way, prior knowledge from experience, by the way. And you're going to hit many dead ends as you do this. I'm going to say secant x times secant squared. That's going to be tangent squared plus 1, right? And then I get dx. Let me make sure I didn't do too much. You know what I'm starting to see now? The problem's coming back at me. Let me write that down for you. So I'm seeing this now. I'm seeing tangent x secant x minus, let's write this down for you, secant x dx, let me keep writing it for you, minus secant x tangent squared x dx. Well, it's a nightmare, but here's the deal. It's equal to this. And I see it right over here. So what I can do now is I can say 2, I mean, at both sides, secant x tan x squared dx is equal to tan x secant x minus secant x dx. All right, here comes a problem. Someone says, I don't know, I have no idea what you're doing. We have this on the left side. On the right side, we have an integration. Would that be agreed? That we've seen before. You may not remember, go back to the prior page. And that's going to be the natural log secant plus tan x, right? I put this over here. Get a bit windy. I gotta close the window. I don't make too much noise. Let's see what you got here. Tan x secant x minus natural log absolute value secant x plus tan x. All symbols of integration have been removed, plus c. What I'm going to do now, divide both sides by 2. We'll check the key later. So it's going to be tangent x secant x over 2. Let's put in one line. Minus the natural log secant x plus tan x. And then when you divide c by 2, I'll just call a new constant d. You can still use c if you want. No, I'm not going to check it. In fact, I'm going to look at the key. And let's look what the key says. Tan x, secant x, I got that. Minus natural log, secant plus tan. Yep, I got that. Well, we did all right. We did all right. All right, I think that's a long problem for us. Let's go to the next one. And let's see if we can do this. And again, no hints being given. But it sure would be nice if I can remember something, right? So I'm going to say I don't like having it all mixed together, like they have double angles with single angles. I'm going to get everything in terms of single angle. Who knows? Maybe it'll help me. And the bottom would be 2 sine x. These are identities that you learn in Math 120. All right. Now, granted, it still may not help. I'm going to split into 2 terms. I pulled the half out, by the way. So let's see, what would you get? You get cosine over sine cosine, which would be cosecant, plus secant. By the way, it sure would be nice if you could remember things, but I certainly wouldn't expect it. If someone said in an exam, hey, what's the antiderivative of cosecant of x? I'd throw it up on the board for you. I would. I wouldn't expect you to remember that. Unless, of course, the question was tell you to derive it, and I gave you the hint like we did in this section over here. But I think for the most part, we have some local memory. Because 1/2, the antiderivative of the cosecant is the natural log of the cosecant x minus cotangent of x. And we just did that secant, right? So plus the natural log of secant x plus tangent x. And then I'll put a plus c over here. Not so bad. Let's see if we got it. 1/2. Yeah, we did. All right. All right, this one over here, again, they're not giving me any hints, but I'll attack it. I'm looking at, I don't like the fact that I get the cosine x minus 1 in bottom. So I'm going to try to find out, like, multiply by its conjugate. And I mean, if it doesn't work, I'll erase it. All right, let's keep going. And when you get there, you get cosine squared x minus 1, right? Dx. Well, the bottom has two terms in it, but I would like one term. I don't know if it's going to work out for me. Cosine x plus 1. And the bottom would be sine squared, right? And certainly, I'm not going to claim that this is going to work out for you, but certainly looking at it, I guess I could probably split into two terms now, right? And it may not go anywhere. And 1 over sine squared is going to be cosecant, right? All right, I got troubles now. And I'm going to do the first integration. I'm going to do it by u substitution. I'm just going to do this one right over here. So I'm going to say u is sine x and du would be cosine x dx. Let's write this one down. I'm just going to do one at a time. Let's see, that's d. I'm sorry about that. So I got 1 du here, and then I got u squared in the bottom. That's u to the minus 2, add 1 to it, minus 1. So minus 1 over u. And what's minus 1 over u? It's 1 over sine, right? Now I'm going to do the other one, and certainly want to remind you is that it sure does look familiar. And let me write this down for you, the cotangent. And someone says, you just did that, didn't you? Yeah, we did, if you remember. And what's cotangent? It's going to be cosine x over sine x. And if I took its derivative, what do you get? Sine squared. I think you remember me just doing this, right? And then you get sine times the derivative of cosine minus sine. So minus sine squared. And then you're going to get minus cosine squared. And that's going to be minus 1 over sine squared. And we just did it. It's cosecant, right? Minus cosecant. So what's this guy's answer going to be? It's going to be minus cotangent. Let's put that down. I erase her out. And make sure I'm not going too quickly with that. So minus cotangent of x minus cotangent of x. And now I'm going to put my constant of integration in over there because I removed the integration symbol. And what does this give you? Minus cosecant x minus cotangent x plus c. And again, I can't say this enough times to you. Mistakes are going to happen. This is why we provide a key for you. And let's see how we did. And I think I made a mistake somewhere. And I'm wondering where I made the mistake. Where did I make my mistake? I got to look at it. I got to find out where I made my mistake. And I made my mistake somewhere. Now I see it. I said something that's not true. And I want to point out where it's not true. And it's just, I guess, brain damage or something. So I said cosine squared x minus 1 was equal to sine squared. That's not true. Let me write this down for you. So sine squared plus cosine squared is equal to 1. And sine squared x is 1 minus cosine squared x. So really, I said something that's not true. This is just the opposite. All right. So I got to go through this now, and I'm going to put down a big minus sign next to this guy over here. I'm going to put a big minus sign next to this guy over here. I'm correcting myself. I'm going to put a big minus sign next to this guy over here. So what do I get? I get this thing over here. So I went back and I realized I made a stupid mistake. So now comes the time you're saying, do you think I would make that mistake again on an exam? No, I'm on the outlook for that now. I'm going to look out for that guy. I know I made a mistake with that. I'm going to pay careful attention not to do that again. Let's look at our answer, see how he did. And I think I did it right. Cotangent X, cosecant. Yeah, I did it right. All right. So a mistake was made and I corrected my mistake. And I'm ready for an exam now. So let me see if I go to the next question. Very next page. Oh, there's no more questions. Okay. Let me read this to you though. Again, even with hints, you might be lost. However, I want to stress that practice will make these problems seem trivial. The reason for giving hints is to push everyone in the same reasonable direction. You should, if resourceful, be able to follow your own lead. Bear in mind, hints are given to guide the practice mind. Okay, so what are you going to do now? How do you become a practice mind? Do homework. And when you do homework, you're going to reinforce some things over here. Again, they're pretty straightforward. You have notes. I've given you some recipes. You can look back over the stuff. I'm not big on memorization, but again, you should also have some resilience and the ability to try things, including things that don't work. It's important you try things. All right. Thank you.